Hi, and welcome back to another video where I'll be teaching you math that you need to know to compete in the Intermediate Math League of Eastern Massachusetts. Now, today is our second and last video in the number theory section of Meet 1. It's actually quite a short section because it's all based around one key concept, which is prime factorization, which we learned in the last number theory Meet 1 video. And if you don't know what prime factorization is, you should definitely try and learn it because everything we're learning today is based around that concept. So if you're confused about it or if you don't know, you can go ahead and check out the first video that I put on number theory Meet 1 because I explained that in that video. But if you do, then you can continue watching this video and we'll dive right into these concepts. So first up, finding factors. So a lot of IMLEM questions are going to ask about specific factors of a number or what the sum of all the factors of a number is. And they might ask about like different attributes of factors of a number. So in order to find those, you need to be able to find all of the factors of a number. So we already learned about prime factorization. That's how you find the prime factors. Right now, I'm going to be teaching you how to find all of the factors. So first you start with your number. So I'm going to be using 200 as an example because I find that the best way to teach this is just through example. So 200 is the number that I'm starting with, and I want to find all the factors of 200. Well, the reason that prime factorization is so important is because you actually need it to find the rest of the factors. Well, I guess you could find all the other factors by just listing all the numbers out below that number and counting, but this makes it more efficient. So first, you find the prime factorization of your number. So my prime factorization of 200 is 2 to the power of 3 times 5 to the power of 2. And so in order to find all the factors, you need to use this prime factorization and a little bit of multiplication in order to get those numbers. And so in order to organize that, you want to make a table. And in this table, you list out all the degrees of each prime factor. And so if you're wondering what a degree is, it's basically just the different exponents of a number. So let me give you an example. Here in my prime factorization, I have 2 to the power of 3. So 2 is my prime factor. So different degrees of 2 would be 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. Now those are all the degrees I'm going to need to list out. If it is 2 to the power of 4 in my prime factorization, then I'd have to list all the way up to 2 to the power of 4 on the table. But since it's only 2 to the power of 3, I don't have to do that. And if you're wondering, I said 2 to the power of 0 and 2 to the power of 1, but I don't actually have that written on my table. Well, the reason for that is I actually do, but it's just simplified. So 2 is 2 to the power of 1, because any number to the power of 1 is itself. And I start with 1 here. You always need to start with 1 when you're doing this, because it's 2 to the power of 0. And here's a rule that you should definitely remember. Any number to the power of 0 is always going to equal 1. So that's the reason that we start with 1 and we don't start with 2 when we're listing out these factors. And then next, on the other column, I list out 1, which is 5 to the power of 0, then 5, which you can think of as 5 to the power of 1, and then 5 to the power of 2, which is the last degree I need to list out, and that equals 25. So then I use this table and I use this organization just to multiply each row in each column, and that's what gives me all of the factors. So this is what it should look like when you're done. So I multiplied in the first row 1 by 1, 1 by 2, 1 by 4, and 1 by 8. In the second row 5 by 1, 5 by 2, 5 by 4, and 5 by 8. And then the third row 25 by 1, by 2, by 4, and by 8. And that gives me all of the factors of 200. So each number inside the table is going to be a factor of 200. And that's how you find all of the factors of a number. So there are 2 formulas that I need to teach you about different things that you can do with factors. And the first is going to be how you find the number of factors that a number has. And the reason I'm teaching you this one first is because it's more relatable to what we just learned, and it's also just a little bit more simple than the next one. So in order to find the number of factors that a number has, and I promise I'll explain what this means. It might look like a lot when I present it. You use this formula. So you multiply a plus 1 times b plus 1 times c plus 1 times d plus 1 times e plus 1, etc. if the values of your exponents in your prime factorization are a, b, c, d, e, etc. So if you understand what this means by what I wrote down, then great. But if you don't, then I'll just explain it in a different way that's a little bit more easy to understand. So if you have a prime factorization, you want to look at what the values of each of the exponents are in that prime factorization. So in this example of prime factorization, I labeled my values as a, b, c, d, and e, and whatever comes after that. But let me use actual numbers as examples. So if my prime factorization was 2 to the power of 10 times 3 to the power of 5 times 5 to the power of 1, then my values of each exponent would be 10, 5, and 1. And what you want to do is take those values of your exponents and put them in this equation that I listed below as each value of each variable. So in the first parentheses where I have a plus 1, that would become 10 plus 1. In the second one where I have b plus 1, that would become 5 plus 1. And then the third one where I have c plus 1, that would just become 1 plus 1. And you would multiply those all by each other. And so I also have d plus 1 and e plus 1 listed in this equation. And the reason I did that is because in my example of prime factorization up here, I had 5 different exponents, which I was showing you. And so for each exponent that you have, you need one set of parentheses. So when I was explaining in the example using a real number or real numbers, I only had 3 examples, so I'd only need to have 3 parentheses. And then if that still doesn't make sense, I'm going to explain it with one last example. So if I'm trying to find the number of factors that 200 has, then first I need to find the prime factorization of 200. So the prime factorization of 200 is 2 to the power of 3 times 5 to the power of 2. So what I do is I first list out my equation, which is going to be a plus 1 times b plus 1. And again, if you're wondering why I only have 2 parentheses here while I have 5 up here, it's because the prime factorization of 200 only has 2 prime factors in it, or 2 exponents. Therefore, I only need 2 parentheses, 1 parentheses for each exponent. So now I want to look at what my exponents are. Since it's 2 to the power of 3, 3 is one of my exponents. And since it's 5 to the power of 2, 2 is another exponent. And so I take those exponents and substitute them in for a and b. So where it was a plus 1, it becomes 3 plus 1. And where it was b plus 1, it becomes 2 plus 1. Because 3 and 2 are my 2 exponents. And then you simplify the equation from there. 3 plus 1 is 4 and 2 plus 1 is 3. And then you multiply those numbers to find the number of factors, which for 200 is 12. And if you're wondering, and you've never seen this before, when you have 2 numbers next to each other, in parentheses like this, then that just means that you multiply whatever's in the parentheses by each other. So in this example, it would be 2 plus 4. In our equation, it was 4 times 3. And that's how you use parentheses right next to each other. And so now I'm just going to quickly try to explain why this works. So if you remember back to when I was telling you about how to find all the different factors of a number, you used a table. And in order to find those factors, you multiplied each number in each row by each number in each column. Well, I used 200 as an example here. So I listed out all the degrees of 200 for 2, all the degrees of the prime factors of 200. So for 2, there are 4 of them. And then all the degrees of 5, which is another prime factor of 200. So in this case, there are 3 of them. And I multiplied those 4 columns by 3 rows. Now, if you look back at our equation, when we simplified it, it just simplified to 4 times 3. So that's essentially what you're doing here. You're basically taking the idea of the table, but you're putting it in a formula so you don't have to find all the values of all the factors, but just how many factors there are. So we multiply 4 columns by 3 rows, and in this equation, we multiply 4 by 3. So I hope that helped explain why this equation works. So the second formula I need to teach you is a formula to find the sum of all the factors of a number. And so I actually didn't know this formula when I competed in IMLEM, and it's definitely something that I should have known, because some questions will say, find the sum of all the factors of, and then give you a very big number, like 1 million. And so you could use the table to find all of the factors and then add that up. but that's going to take a really long time, and you only have 3 minutes and 20 seconds per each question. You get 10 minutes for 3 questions, so that simplifies to 3 minutes and 20 seconds per question. And so if I had to add that up by each individual factor, that would be pretty slow. So the formula I'm about to teach you will allow you to speed that up. So I'm going to present something in a sec. I promise I'll explain what this means again. So if the prime factorization of a number is 2 to the power of a times 3 to the power of b times 5 to the c times 7 to the d, etc., then the sum of the factors of that number is going to be 1 plus 2 to the power of 2 all the way up to plus 2 to the power of a times 1 plus 3 to the power of 2 all the way up to plus 3 to the power of b, and so on. So if you understood what that meant, then awesome. If you don't, no worries about it. It's a little bit complicated. Let me explain it a little bit more. So say I had an example. So say my prime factorization was 2 to the power of 3 times 3 to the power of 6. Then I'd want to look at what my exponents are and figure out what the highest degree of each prime factor is in that prime factorization. So for 2, it'd be all the way up to the 3rd degree because you have 2 to the power of 3. And for 3, it'd be all the way up to the 6th degree because you have 3 to the power of 6. So when I'm writing out my formula, then what I want to do is add all the degrees of each prime factor all the way up to the highest degree in the prime factorization. So what that means is I start with 2 to the 0, which is just 1, which is why I wrote 1 here in this example, and then add that to 2 to the power of 1, which is just 2, so I don't actually need to write to the power of 1, then plus 2 to the power of 2, and then you go all the way up to whatever your highest degree is. So in my example, I only had 2 to the power of 3, so then I'd add 2 to the power of 3, and then be done with that parentheses. And then you multiply that by whatever all the degrees all the way up to the highest degree in your prime factorization is of your next prime factor. So I had 3 to the power of 6 in this example. So I would add 3 to the power of 0, start with my lowest degree, which is just 1, plus 3 to the power of 1, plus 3 to the power of 2, and then so on until I get all the way to plus 3 to the power of 6, because 6 is the highest degree which shows up in my prime factorization. And that's what this means. When you have 1 plus 3 to the 2 all the way up to 3 to the power of b, 3 to the power of b just means the highest degree that you have in your prime factorization. So in my example, it was 3 to the power of 6. So I hope that made sense. And if it didn't, I'm going to explain it with one last example. So again, I'm going to be using 200. You might be sick of this prime factorization, but again, you always have to find the prime factorization first. So the prime factorization of 200 is 2 to the power of 3 times 5 to the power of 2. So when I write out this equation, I'm only going to need 2 parentheses. So this is what it's going to look like. So my sum of my factors will equal 1 plus 2 to the power of 2 plus 2 to the power of 3 times 1 plus 5 to the power of 2. And so the reason I do this is because I list out all of my degrees up to the highest one. So for 2, it's going to be 2 to the power of 3. And for 5, it's going to be 5 to the power of 2. And I start with whatever that number is, whatever my prime factor is, to the power of 0, which will always be 1. So here, if you want to think about it this way, I'm adding 2 to the 0 plus 2 to the 1 plus 2 to the 2 plus 2 to the 3. And then multiplying that by 5 to the 0 plus 5 to the 1 plus 5 to the 2. So then what I want to do is simplify my equation by first taking the exponents and simplifying those. So I have 1 plus 2 plus 4, which is 2 to the power of 2, plus 8, which is 2 to the power of 3, times 1 plus 5 plus 25, which is 5 to the power of 2. So you simplify those, and then you have to add them first before multiplying. If you remember, just because that's the way that the order of operations works, you do whatever's in the parentheses first. So you add those numbers. So 1 plus 2 plus 4 plus 8 is 15. And 1 plus 5 plus 25 is 31. And the sum of the factors is whatever these two numbers multiplied by each other is, which in this case, for the sum of all the factors of 200, is 465. And so I'm not going to explain why this formula works because it's a little bit complicated, so it would be difficult for me to explain. It's already difficult for me to explain some of the reasons why other formulas work, but just know that this is what you do to find the sum of all the factors of a number. You list out all of the degrees of each prime factor, add them, and then multiply them by the sum of all the other degrees of all the other prime factors. Okay, so now going over what we just learned, we're going to do two review questions, one about the first formula and one about the second. So if you want to try these questions, I'll give you a few seconds to pause the video, and then I'll go ahead and explain them. So the answers to these questions were for the first one, 8, and for the second one, 93. So let's go ahead and explain them. So the first step for both of the questions actually, but we'll start with the first one, should always be to find the prime factorization of your number. It's super important, so let's go ahead and do that. So I start with my number, 40, and if you don't remember how to use the tree diagram, this will be a good review. So I take 40 and I break it up into two factors on different branches of my tree. So I'm going to break it up into 20 and 2. And I know that 40 is divisible by 2 because it ends in a 0. And if you remember that divisibility rule, any number that ends in 0 to 4, 6, and 8 will be divisible by 2. So I can break 40 up into 20 and 2. It's 20 times 2 multiply 40. So now 2 is a prime number, so I can't break that down further. But 20 isn't a prime number. In fact, it also ends with 0. So I know again that 20 is divisible by 2. So I'm going to write 2 here, and then whatever multiplies by 2 to get 20, I'll write here, which is 10. So again, 2 is a prime number, so I can't break that down any further. But 10 is not a prime number, because again, it ends with a 0, so it's going to be divisible by 2 one more time. So I'm going to divide it by 2. 10 divided by 2 is 5, so I'll write 2 here, and I'll write 5 here. And now I'm left with 4 prime numbers. 2 can't be broken down further, and 5 can't be broken down further. So that's my prime factorization done. So the prime factorization of this number is going to be 2 times 2 times 2, because I have 3 2's in this diagram. 1, 2, 3. Oh, that was ugly. Let me fix that. There we go. Times 5. And if I want to simplify that into exponential notation, which is what you should do because you need it for this formula, is 2 to the power of 3 times 5. Or if you want to think of it this way, 5 to the power of 1. So now in order to use this formula, since I have 2 different prime factors, I only need 2 parentheses. So my formula for finding the number of factors that 40 has is going to be a plus 1 times b plus 1. Again, 2 parentheses because I have 2 prime factors. So there's my formula. So now the values of a and b are just going to be the values of my different exponents. So the exponents in this prime factorization is, since I have 2 to the power of 3, 3 is going to be one of them, so 3 plus 1. And then the other one is going to be 1, since I have 5 to the power of 1. So 1 plus 1. And so I substituted in 3 and 1 for a and b. And so now I can just go ahead and simplify this equation. So it becomes 3 plus 1 is 4 times 1 plus 1, which is 2. And then if I multiply 4 by 2, that leaves me with 8. And so the amount of factors that 40 has is 8. Okay, cool. So I'm going to go ahead and clear that. If you want to look at it and just break down what I did, you can pause the video, but I'm going to clear it in a sec. Okay, so the sum of all the factors of 50. That's what we need to find, so that's my next question. Again, the first thing that you should do is find the prime factorization of the number. So I have 50, and I'm going to make a tree. So I know that 50 is divisible by 2 because it ends in a 0. So I'm going to write a 2 on the left side, and then 50 divided by 2 is 25. So I'll write 25 here. So if I divide 25 by 25 into different prime factors, I'm going to get 5 and 5. And the reason I divided 25 up and not 2 is because 2 is a prime number, 25 isn't, so I can divide 25 up further. So 25 is divisible by 5 because it ends in a 5. That's just good review if you remember your divisibility rules. And then, so since 25 is divisible by 5, then in order to get to 25 by multiplying by 5, you also need another one. So I'll write 5 here as well. So now I've finished breaking up 50 into its prime factors because 2, 5, and 5 are all prime numbers, so nothing can be broken down further. So then my prime factorization is going to be 2 times 5 times 5, because I have 2 5s in this tree diagram. And then if I simplify this into exponential notation, it'll be 2 to the power of 1, which you don't have to write, but I'm going to write it for this purpose, times 5 to the power of 2. Okay, so my question is, what is the sum of all the factors of 50? So the sum formula is going to be listing out all the different degrees of each prime factor up to their highest degree, adding them, and then multiplying by each other. So I'm going to go ahead and do that. So first I start with my first prime factor, which is 2, and start with 2 to the power of 0, which is 1. And then I add that to 2 to the power of 1, which is 2. And then I don't do any more just because I don't have any higher degrees of 2. And then I move on to my next prime factor, which is 5. So I start with 5 to the power of 0, which is 1. Add that to 5, which is 5 to the power of 1. And then add that to 25, which is 5 to the power of 2. And then I don't add any more because, again, I don't have any higher degrees. So now I have 1 plus 2 times 1 plus 5 plus 25. So if I simplify this, 1 plus 2 is 3. 1 plus 5 plus 25 is 6 plus 25, which is 31. Then if I multiply 3 by 31, that leaves me with 93 as the sum of all the factors of 50. So next we're going to talk about square and cube numbers. And you might already know what these are, and you've definitely been dealing with them as I've been teaching you, but I'll go ahead and explain it. So first, a square number is a number that can be created by multiplying the same number by itself twice. And then a good rule about square numbers is that they always have an odd number of factors, which is different than a regular number because a regular number always has an even amount of factors. And I guess we'll try to explain why this happens. It's because when you have a factor of a number, say 2 is a factor of 10, each factor is always going to have a factor pair. So the factor pair of 2 is going to be 5 if 10 is my final product, because 2 times 5 equals 10. So no matter how many factor pairs you have, since you have 2 numbers per factor pair, that's always going to add up to an even number of factors. But with square numbers, one of your factor pairs is going to have only one number in it because it can be multiplied by itself, not another number, to get your square number. So when you add that on top of all your other factors, that's going to add to an odd number of factors. So some examples of square numbers are 1, 4, 9, 16, 25, 36, 49, and 64. And so those can be created by multiplying 1 by 1, 2 by 2, 3 by 3, and so on until we get to 8 by 8. So there are more square numbers than that. I only listed the first 8 here, and I encourage you to go and find out what the other square numbers above this are. And they're just good to memorize and good to know in case they ever show up in a question. You can be like, oh, that's a square number. So these are just the first 8 square numbers though. Next, cube numbers. Cube numbers are a cousin of square numbers that can be created by multiplying the same number by itself 3 times as opposed to twice, which is how you create a square number. And so that's pretty simple. Cube numbers, be careful, are always going to have an even amount of factors for their own reasons. And then some examples of cube numbers are 1, 8, 27, 64, 125, 216, 343, and 512. And again, those are just the first 8 cubic numbers. I encourage you to go and find out what the ones above that are, but these are just the first 8. So the last thing that you need to know for number theory meet 1 isn't really a concept or formula or equation. It's more about a type of question. So this type of question is really unique, which is why I thought I'd go over it. So that question deals with creating divisible numbers. Some questions are going to ask you to find certain numbers with certain attributes and factors. And so here I have an example question which fits that category. So this question reads, what's the lowest positive number which is divisible by 1, 2, 3, 4, 5, and 6? And so it's creating divisible numbers because you need to create a number that is divisible by 1, 2, 3, 4, 5, and 6. And it also has to be the lowest positive number which fits that description. And so you actually already know everything you need to in order to solve these questions, but they can be a little bit tricky. So that's why I want to go over them. So if I'm going over this question, and if I just looked at it at one glance, you might think, oh, well, that's easy. You multiply 1 by 2, by 3, by 4, by 5, and by 6, and boom, you created the right number. You got 720. No, that's actually incorrect. And the reason for that is you haven't simplified the number, or you haven't simplified what you're multiplying, should I say. So 720 is divisible by all of these numbers, but it's not the lowest positive number, which is divisible by 1, 2, 3, 4, 5, and 6. And in order to explain that, it's your favorite, we have to look at the prime factorization of the number that we need to find. So the prime factorization of this number that we're trying to find is going to be 2, because that's one prime factor that we have when we're multiplying this, and it needs to be divisible by 2, times 3, that's another prime number that it needs to be divisible by. And then this is where it gets tricky. You might think you need to multiply by 4, but you actually don't. You only need to multiply by 2 again. And here's the reason why. Because you've already multiplied by 2 once. The prime factorization of 4 is just 2 times 2. So if you add another 2 to the equation, then it's already going to be divisible by 4. Because if you simplify this part of your prime factorization of the number we're creating, then this just simplifies to 4 times 3. So if you just multiply by 2 again, it's going to simplify to 4 times 3, and the number is going to be divisible by 4. And then times 5, because 5 is another prime factor you need. And then you don't need to multiply by 6. And it's the same reason we don't need to multiply by 4. Because 6 is just going to be 2 times 3. That's the prime factorization of 6. And in this equation, you already have 2 times 3. So if you simplify that, then it becomes 2 times 6 times 5. So this number is already divisible by 6 with the prime factorization we created, which is why this 1 times 2 times 3 times 4 times 5 times 6 is redundant. It gets you 720, but 720 is way higher than the lowest positive number, which is divisible by all of these. So 2 times 2 times 3 times 5 is going to equal 60. If you think about it, 60 is divisible by 1. Every single number is divisible by 1, or every single natural number. 2 is divisible by, or 60 is divisible by 2. It's divisible by 3, 4, 5, and 6. And so you need to make sure you figure out the prime factorization of these numbers when it's asking you these questions. And that's why these questions are tricky, because you can't just approach them with a simple approach and just assume it works. You actually need to make sure it works by diving into what the prime factorization of these numbers is going to be. So the next question I wanted to go over, this is another typical question with a really weird format. It says, find the sum of the values of A, which 31,240A is a multiple of 6. And so that's not an actual number, 31,240A, unless you give a value to A. A is just a variable. Remember, variables just represent a number. So A could be 7, for example, and this number could be 31,247, or A could be another number, but it has to be a one-digit number. So the question says, find the sum of the values of A, in which 31,240A is the multiple of 6, which means it's divisible by 6. So in order for a number to be divisible by 6, if you remember back to our divisibility rules, it has to be divisible by 2 and it has to be divisible by 3, because 2 times 3 is 6. So in order for this number to be divisible by 2 and 3, let's list out the conditions. First, A has to be an even number. So let me write that down. A needs to be even. Because if it ends in an even number and A is the last digit, that's what we call a unit digit, then the number will be divisible by 2. And then in order for it to be divisible by 3, A plus all the other numbers, so plus 3 plus 3 plus 4 plus 2 and then plus 1, needs to equal a multiple of 3. Multiple of 3. Let me expand this text box. And so I'm just going to simplify that a little bit. So which means a plus 3 plus 4 plus 2 plus 1, which simplifies down to 10, needs to be a multiple of 3. So a plus 10 is a multiple of 3. So now you've created a few conditions in which the value of a will make this number, 31,240a, a multiple of 6. So now we just need to figure out numbers that match both of these conditions. Well, let's start with 1. So if a were 1, then it wouldn't match either of the conditions because 1 is not an even number. And then 1 plus 10 is not a multiple of 3 because 1 plus 10 is 11 and 11 isn't a multiple of 3. So we can immediately say that a cannot be 1, 3, 5, 7, or 9 because none of those numbers are even. And we know that a needs to be an even number. So that means the numbers that we haven't tried are 2, 4, 6, 8, and that's it. So we have 2, 4, 6, and 8. Oh, sorry, that's not it. I forgot 0. Right, a can be 0 as well. So now we need to try all of these numbers. So we know that all of these numbers fit the first condition. A needs to be even. So now we just need to check, do any of these numbers plus 10 equal a multiple of 3? So we'll start with 0. A plus 10, or 0 plus 10, is not a multiple of 3 because 10 is not a multiple of 3. So a can't be 0. Next, 2 plus 10 is a multiple of 3 because 12 is a multiple of 3. So a can be equal to 2. So I'll write that down. But don't stop here because we're not done yet. We haven't tried the other values, and there can be multiple values of a for which this works. So we need to make sure that we continue to get all the values of a because we need to find the sum of them. So next, a can't be 4 because 4 plus 10 is 14, and 14 isn't a multiple of 3. Next, a can't equal 6 because 6 plus 10 is 16, and that's not a multiple of 3. And then our final number, 8, a can be 8 because 8 plus 10 is 18, and 18 is a multiple of 3. 18 divided by 3 is 6. So I can also write down a equals 8. So now I have my two values of a, and I use deductive reasoning. I figured out some conditions where a needs to be a number in order to find these values. So now I have a equals 2 and a equals 8, and the question asks, find the sum of the values of a when they fit these conditions. So I just need to do 2 plus 8, which leaves me with my final answer, 2 plus 8 as 10. So my final answer to this question would be 10. And that's how you approach these types of questions. You just need to think about the conditions in which you can create this number and still fit all of the things that the question is asking. So for the first one, it was what conditions can we create this number and make it the lowest number that's divisible by all of these? And then for the second one is in what conditions can we make a divisible by 2, or sorry, in what conditions can we make this number divisible by 2 and divisible by 3? And we're going to finish off this video with a review question on creating divisible numbers. Again, I said these questions can be tricky, but here's an example of one of those questions. And if you want to try it, I'll give you a few seconds to pause the video, which you should do now, and then I'll explain the answer. So the correct answer to this question was that x equals 36. And so the way we approach this question is, again, we need to create conditions in order to find this number. Well, this question is actually a little bit more simple because it directly gives you the conditions in the list, which is a lot easier to deal with than the questions before. So it's not as tricky, but we're still going to go through it. So in this question, we have 5 different conditions. X is a positive number. X is a 2-digit number. It's a square number. It ends in a 6. And the difference between x's digits is 3. So let's go through each condition, and then we need to eliminate numbers based off that condition. So first, x is a positive number. So in order to eliminate some numbers, we can basically say that x is a natural number. Because if you remember, natural numbers are all numbers that are 1 and above without a fraction or a decimal. Or if you just want to make it simpler, x is a positive number, right? So x can't be negative. So x has to be greater than or equal to, I don't have a greater than or equal to sign here, so I'm just going to write it like this. X is greater than or equal to 0. Sorry, x is greater than or equal to 1. So, next condition. X is a 2-digit number. Well, so we know it can't be negative. So in order for x to have 2 digits, x has to be in between 10 and 99. Because 10 is our first positive 2-digit number, and then 99 is our last positive 2-digit number. Because the number above 99 is 100, and that is 3 digits, and then all numbers above 100 are going to have 3 or more digits. So x is in between 10 and 99. So next condition, x is a square number. So now we've eliminated enough numbers that we can just start listing out possible numbers that x can be. So square numbers in between 10 and 99 include, so first we have 16, which is 4 times 4. Then we have, after that, 25, which is 5 times 5. 36, which is 6 times 6. Then we have 49, which is 7 times 7. 64, which is 8 times 8. And then I didn't give this one in the examples of square numbers, but the next one is 81, which is 9 times 9. And then after that, we have 10 times 10, which is 100, but we're not going to list that because it's not between 10 and 99, and it is 3 digits, so it doesn't fit our condition. So next we can move on. So x ends in a 6. So we've already eliminated it down to 6 numbers here. We can eliminate it down to just 2, because only 2 of these square numbers end in a 6, and those are 16 and 36. 16 and 36. So x could either be 16 or 36 based off these 4 conditions, but we have one more in order to find the value of x. So the difference between x's digits is 3. So the difference between 6 and 1 is 5, so x can't be 16, but the difference between 6 and 3 is 3. So that means x can be 36. So x has to be equal to 36, and that's our answer. So I'll just quickly go over what we've learned today. So first, we learned how to find all of the factors of a number. And we do that by first getting our number and finding the prime factorization, then creating a table where we list out all of the degrees of the prime factors on the edges and multiply those out in rows and columns in order to find all of the factors of a number. And we used 200 in this example, listed out all the degrees of 2 and all the degrees of 5 from our prime factorization, and found 12 different factors of 200. So next we talked about how to count factors, and we actually talked about a formula to count the number of factors, which is a plus 1 times b plus 1 times c plus 1 and so on, if a, b, c, and so on are your different exponents of your prime factors. And then in order to explain it further, we used an example where we found 200's prime factorization and substituted in 3 and 2, which are our exponents, into the equation, simplified the equation, and found that 200 has 12 factors. And then we quickly went over why this works, because we're basically emulating what we do when we create this table, which is multiplying 4 rows by 3 columns in this example. And we're just putting that into a formula so we can find it more quickly without actually having to find all of the factors of a number. Next, we went over a formula to find the sum of all the factors of a number, which was 1 plus 2 plus 2 to the 2 all the way up to plus 2 to the a, times 1 plus 3 to the 2 all the way up to plus 3 to the b, and so on. We're basically just listing all the different degrees of each prime factor of a number, adding them, and then multiplying those sums by each other. And then in order to further explain this, we went over one more example where we used 200 again, found the prime factorization, and then put the sum of the factors as all the different degrees of those numbers added, and then we just simplified it until we found the sum of the factors of 200 is 465. Then we went over 2 review questions, reviewing first how to find the number of factors, and then second how to find the sum of the factors, and those were 8 and 93 for 40 and 50 respectively. Then we went over what square and cube numbers are. A square number is a number that can be created by multiplying the same number by itself twice, and we learned that they always have an odd number of factors, which I explained. And then we just looked at examples of a few square numbers all the way up to 64, which is our 8th square number. Then we learned about cube numbers, which are the cousin of square numbers and can be created by multiplying the same number by itself 3 times. And then we looked at some examples of cube numbers. You probably can't see the ones at the bottom, sorry. All the way up to 512, which is the 8th cube number. And then we talked about, finally, types of questions in number theory where they ask you to create divisible numbers, which means creating numbers that fit certain conditions. And we did 2 examples here, one about finding the lowest positive number, which is divisible by 1, 2, 3, 4, 5, and 6, where we had to use prime factorization in order to find it. And then a second where it asks you to find the sum of the values of A, in which 31,240A is a multiple of 6. And then we had to use our divisibility rules and simplify what 6 means, which is 2 times 3, in order to find the value of A. And then finally, we went over a review question where we had to find the value of X under certain conditions where it's a positive number, a 2-digit number, a square number, it ends in a 6, and the difference between X's digits is 3, and we found that to be 36. So that's the end of this video. And that's actually the end of the number theory section for Meet 1 because it was a relatively short section and it was all based around prime factorization, which we learned in our first video. You should be a master of that by now because we've gone over it a lot of times. Right, but that's all I have for you today, and I'll see you next time.